Section 3.4 is taking a look at exponential and logarithmic equations. In this video, I'll go over 4 specific examples, but please make sure to check out the Canvas notes for more examples to help you with homework. Let's look at example A. Let's solve for x. I have 3 raised to the 3x equals 9. The first technique I'm going to show you is making both the left and the right hand side have the same base. So on the left I have 3 raised to the 3x. On the right I have 9, but I can rewrite 9 as 3 squared. Now both my left and right hand side of the equal sign have the same base, 3. So if my bases are the same, that means my exponents must be equal to each other. Dividing both sides by 3, and I get x equals 2/3. Let's take a look at another example. This time I have 2 raised to the x equals 3 raised to the 5 minus 4x. In this particular case, there's nothing I could do to the bases to make 2 and 3 the same number. So I have to come up with another technique for solving this problem. I need to solve for x, but right now my x is in the exponent position. The only way I can remove x from the exponent position is using my log rule, specifically the power rule, which I covered in the last section. So, in order to use that rule, I need to have log in my problem. So, first thing I'm going to do is log both sides of my equal sign. Now, I'm going to use the power rule, which states my exponent can move out front and become multiplication. So, I have x times log 2 equals 5 minus 4x log 3. Now it's really important to remember to use those sets of parentheses right there. It's your responsibility to make sure you put those parentheses in. Alright, on the left hand side, there's nothing I can do, so I'm just going to rewrite x log 2. On the right, I need to distribute. Remember, log 3 is just a number, and I need to distribute that inside my set of parentheses. So it's going to say 5 log 3 minus 4x log 3. Again, my goal is to solve for x, so the first thing I want to do next is bring all my x's to one side of the equal sign. So I'm going to go ahead and add 4x log 3 to the left. On the right, that's going to cancel out. Now on the left, those aren't exactly like terms. One's a log 2, one's a log 3. So all I have to do is write it side by side. Alright. Now again, I need to solve for x. Right now I have x in 2 different locations. So from going to writing x twice on my paper to writing it once on my paper, I need to factor out an x. So GCF, x times log 2 plus 4 log 3. And last but not least, last step, opposite of multiplying is dividing. On the left, that's going to cancel out. X is now by itself, and x equals 5 log 3 divided by log 2 plus 4 log 3. Now for me, as soon as x is by itself, you can stop. I don't need you to do more rules, more simplifying. At this point, I'll go ahead and let you leave your answer like that. Let's take a look at another potential example. I have e raised to the 2x minus e to the x minus 6 equals 0. This kind of looks like a quadratic with base e to the x. So to help me solve this, I'm actually going to do what I call a little substitution. Take some other value, or letter, I'm going to just use the letter U, and I'm going to set that equal to e to the x. Because I can rewrite this as e to the x squared minus e to the x minus 6 equals 0. And now everywhere I see e to the x, I'm going to replace it with the letter u. So I'm going to get u squared minus u minus 6 equals 0. Now it's officially a quadratic. I can factor this problem. Two numbers that multiply to -6 but add to -1, that's going to be -3 and +2. Solving for u, I get u equals +3 and u equals -2. Now that looks like you're done, but not quite. You just solved for the letter u, but in the original problem, I wanted to solve for the letter x. So, after you have u, you need to go back into your substitution and solve for x. So that means I'm going to have 3 equals e to the x and -2 equals e to the x. Now to solve for x, since I have base e, I'm going to take the natural log of both sides. So I'm going to have ln 3 equals ln e to the x. Power rule says ln 3 equals x ln e. One of our basic properties, we know ln e is the value 1, so 1 times x is x, and so ln 3 equals x is one solution. Alright, let's go up to the other one. I'm going to have ln -2 equals ln e to the x. Uh-oh, I just took log, or natural log, ln of -2. That is not in the domain. Remember, the domain of a logarithm is from 0 to +infinity. I cannot take the log of a negative number, so this side produces no solution. So this exact problem, e to the 2x minus e to the x minus 6, has one solution where x equals ln 3. And let's take a look at one last example of solving. I have log base 2 of x minus 3 plus log base 2 of x minus 4 equals 1. I want to solve for x. The first thing I see is I have two logs adding each other. Let's go ahead and condense that, and that's going to be log base 2 of x minus 3 times x minus 4 equal to 1. Next, I want to get rid of the word log. Eventually, I'm trying to get x by itself, so let's change this from logarithmic form to exponential form. So that's base 2 to the 1 equals x minus 3 times x minus 4. Continuing to solve, 2 to the 1 is 2. Foiling, we're going to get x squared minus 4x minus 3x plus 12. Like terms in the middle, that's x squared minus 7x plus 12. Let's set this quadratic equal to 0, so subtracting 2 to the other side, I get x squared minus 7x plus 10. Solving the quadratic, this problem should factor two numbers that multiply to 10 and add to -7. That's going to be -5 and -2. Solving for x, I get x equals 5 and x equals +2. Came out nice and pretty. Looks like my problem has two solutions, but I really need to do a double check. Remember, this is a log problem. I need to watch out for my domain. So let's go back up to the top and let's check if 5 and 2 work. When I plug a 5 into here, 5 minus 3 is 2. That's log of a positive number. We're good. When I plug 5 into here, 5 minus 4 is 1. That's log of a positive number. 5 checks out. Let's see what happens when I plug in 2. If I plug 2 in for x, I'm going to get 2 minus 3, which is negative 1. And I cannot take the log of a negative number, so 2 is out. 2 does not work, but 5 does. So again, you do need to double check your final answers for your x values to see if they actually work in your equation. So this particular problem has one solution at x equals 5.